Alright people, like I promised, I said I was going to go through the tree diagram when it involves replacing and not replacing the item. We've gone through replacing, now we're going to go through when it involves not replacing the given item. Here we have a question being asked. Suppose that we have 3 oranges and 4 apples. They are to be selected from a box. Now they want us to use a tree diagram to determine the probability of randomly selecting 2 oranges without replacement. That's what we're going to go through now. And an apple and an orange, I want to use also the second version in any order, and then at least 1 apple. First things first, what do? Sketch our Venn diagram. Here we have 2 items being selected one after the other. So we have 2 oranges, an apple and orange. That means we have a double draw. That's the consideration. Sorry, everything was not written down here because of space, but I will do the explanation. We have 2 draws or 2 selections being made. If the first was an orange, if the second was an orange, this first action shows that we can either have an orange or an apple. Like I said, check the number of items given to you. They gave us 3 oranges and 4 apples, so 3 plus 4 is 7. That's the total number of outcomes. Remember, probability formula is number of possible outcomes for any event divided by the total number of outcomes. The number of possible when we are choosing an orange here is 3, and the total item we have in that box is 7. Here we also have 4 out of 7. This is the first action. If we have a second dip or a second selection, it could also be either an orange or an apple. If the first selection from the box is an orange, the second could be an orange or an apple. If the first selection was an apple, the second can also be an orange or an apple. Now, how do we go about this when the first selection was not replaced? Now, if I select the first one and it is an orange, out of 7 items, this is what happens. My orange, if I select an orange, that means I have 2 left in the box because I've taken 1 orange. So the number of possible outcomes for orange for the next draw will be 2, because for the first draw I took out 1, so I have 2 left. Now remember that the 1 I took out also affects the total. It was 7 because I've taken out 1 item. 2 plus 4 will now give us 6. So I have 2 out of 6 as my probability for picking the second. Now if I took an orange in the first one, I did not touch my apple. Yes, I have 2 plus 4 as the outcome. But remember, my apple is still 4. So I will still have 4, but in this case, out of 6. Now, let's go check the case of an apple. If I pick an apple in the first place, I have 4 apples. That means I'm left with 3 apples. I'm left with 3 apples. If the first draw was an apple, I'm left with 3 oranges and 3 apples now. So my next option for an apple, I have 3 options. But I have also reduced the total number of outcomes, so I have out of 6. But I did not touch my orange. If I'm going through this path, I chose an apple. So my orange is still intact. I still have 3 of them, but now the total number has reduced to 6. So this is what happens when we are working around not being replaced. Remember, this is the idea of you must look out for that explanation if they're asking you if the first item was replaced or not replaced. So here we have outcome orange, 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 apple, apple, orange, apple, 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 apple. And if we check what is happening here, they want us to get the probability of 2 oranges. So probability of orange, orange is going to be, we flow that path, 3 over 7 times 2 over 6. This will give us 6. 7 times 6 is 42. Always remember to reduce this to the lowest possible. So this will give us 1 over 7. Now we go again. We go again. The second question says, an apple and an orange, I promise that I'm going to do it differently this time. So let's wipe some cards so that we have enough space to work around. Meanwhile, let's go to, this is the first question, let's go to the last question. In this case, I have, what is the probability of at least one apple? At least one apple means one or more. One. So this is the only option. So we can have probability of the same, not orange. And not orange in this case is 1 minus probability of orange. 1 minus probability of orange is, this is the probability, so we have 1 minus 1 over 7, and that will give us 6 over 7. In this case, for not being replaced, we have probability of not orange, or at least one or more, as 6 over 7. And then the next thing we have here, we omitted is an apple and orange. I want to consider all options. They said an apple and an orange. In any order, they didn't give us the order. So we must consider all the cases where we have one apple, one orange, one apple, one orange. So I would say it can be probability of an apple before an orange, or probability of an orange before an apple. So 1. And the probability, they all translates to plus. So we will get the probability of apple orange. Apple orange is 4 over 7 times orange is 3 over 6 times orange apple is 3 over 7 times 4 over 6. So when we simplify this, whatever it gives us, that's the answer. Here we have 12 over 42 times 12 over 42. Whatever it gives us, that is our final answer. So this is how we approach getting through the tree diagram, random selections when being replaced or not being replaced. Please pay very good attention to probability problem. The language is a little bit different. You must read to understand. Like what I did here, at least one apple, they can say in any order, at least one apple, one or more. An apple and an orange can be in any order or specifically an apple before an orange. So you have to pay attention to the question to understand what you are supposed to do. If it is being replaced, they will tell you. If they want it when it is not being replaced, you will also be notified. Read and ask questions, and do let me know. Please share this video and